Good morning. So today in the control system and PLC, we'll be going through block diagram reduction. So this subject we are having in sixth semester. Let us go with there are some rules to be followed for block diagram reduction. Those rules could be, there are 8 to 10 rules. So you can refer those rules from any of a textbook as mentioned in the syllabus. We'll take one example and I hope that we'll be able to cover all those rules in that example. Okay. So basically what happens now, to identify, to find out whether the system is stable or not, or to find out other parameters, any kind of a system is first converted into a block diagram. That you have seen in your previous lecture, why the block diagram is important. And if you can remember, somewhere we have taken even lectures to identify the stability of a system depending on Laplace transformation. You must be able to remember that as well. So both the sense, if there is a big system where there are multiple blocks available, that system need to be first transferred into a system which will have only one block. So that is what we call it as a block diagram reduction. If you see that in this particular system, in an example, we are having few blocks. Okay, few blocks, the blocks which are coming on a forward path. Forward path means what? If you are starting from the input side and if you are approaching to the output side, whichever block coming between, we call them as a forward blocks. And we generally, the input is represented as R, output is represented as C, and the forward blocks, we call it as, those forward blocks are represented as G. These G nothing but represent gain. Okay, so whatever input you are giving to that particular block, so that input will get multiplied with G1 and it will appear at the output of that particular block. So this is nothing but a gain kind of thing. So if you can see that in this example, we have one this forward path, we have one this forward path, we have another one as this forward path. So there are 3 forward paths for this particular example. So now one is this is the way it is going there. The another one is a straight way like this. The third one is coming like this. Okay, now in between you can observe that there is a kind of backward movement as well. There is a kind of backward movement. This backward movement is nothing but we call them as a feedback. And like gain, we are having a forward gain, we represent it as G. This is reverse, this is feedback gain. So we represent it as H. So now H3, this is one feedback gain. We are giving it back. So here again you are giving it back. Now again here as well you are giving it back. So there are 1, 2, 3 kind of feedback gains available in this particular example. Another thing is you can find out some blocks there like this. We call them as summation blocks. So these are nothing but summation blocks. Okay. So you can see that there are, it could be multiple input, like here there are 2 inputs. No, one is coming as this. If anything is not represented, we consider it as plus, and another one as this. So this is also plus. So 2 plus are coming there. Okay. Now on this side, if you see this plus and this is minus. So whatever coming to this way, it will get added with this and is subtracted from that. So these are nothing but a summing point. So there are 1, 2, 3 and 4 summing points are there. There are 4 summing points. Now furthermore, you can observe that there are takeoff point, like a takeaway point or takeoff point. So these are takeoff points. One as this, another one as this, another one as this, and one as this. So there are again 3 takeoff points available in this example. Got it? Now you must have understood the path, forward path. Whatever comes on a forward path we'll call as a forward gain, and that thing will get multiplied to the input and appear at the output of that particular block. Okay, there are things Even reverse path is also available. So whatever comes on a reverse back path, we call them as a feedback, and whatever appears there, the block appears there, we call them as a feedback. Okay, feedback gain. उसके बाद में next thing is you can see that there are some summing points and there are some takeoff point. Now to solve this, to reduce this, we have to apply, I told you, some rules. There are 8 to 10 rules which you can refer to the books. That books are available, those rules. I'll share the link as well here. If I find out anywhere to this video, you can click on that and you can see those rules, whatever rules available. So now in this case, we have to identify first whether there are two consecutive blocks available or not. This is very first step which you have to find out. Okay, just observing this, identify where there are two consecutive blocks. If they are available, we have to club it. Then in that case, gain will get multiplied. Gain will get multiplied. Suppose here there is summing point, then block, then summing point, then block, then summing point, then block, then takeoff point, and then block. So you can observe that these two blocks are near to each other. Okay, but in between there is a takeoff point which is making difficult for us. So now this takeoff point can be moved here or it can be moved here. It can be moved afterward as well. So there are two possibilities of moving it out. So that comes under another rule. Okay, I am talking about the first rule. After that first rule, we have to identify that there are two blocks which are there in cascade, next to each other, and there should not be anything between them. And if such kind of blocks are there, you have to just multiply the gain of those blocks. Unfortunately, we are not able to find out that kind of thing very clearly in this, so we have to go for another rule. Like in this case, I told you to go for another rule. Now, if you observe these two are connected in parallel. They are in parallel. And for the first thing is series. Cascade is series. No, I told you these two could be in series. ये take off point नहीं रहता था तो वैसे these two are in parallel. Okay, so this can be reduced. This can be reduced to one block. So how should we reduce? See, suppose here, if you see that this is, suppose if we related this input as A, okay, so this A is appearing here with A G1 as I told you, and A appearing here as A G5, and both of them are getting added. So this particular thing can be replaced with a one block, like it could be replaced with a one block. And that block will be a new block, okay, and that block should be addition of both G1 plus G5. What my point? So ultimately what will happen? Ultimately, if you go from this path, A is getting multiplied to G1 and G5, and here we will get A into G1 plus G5. Exactly the same what we want, we are getting it here. So we are not disturbing anywhere the performance of a system. We are not touching out anywhere, but we have reduced two block into one block. So this is what is a first step. You have identified whether there are any blocks in parallel and you have just reduced them. Got it? So this is a very clear-cut first process which you have done in it. Next thing is we have to shift either this summing point to that side, then these two will be in series, or we have to shift this to that point. They could be in series. Like one can make G2, G3 in series, or one can make G3, G5 in series. Now here there are multiple ways to solve the problem, and that is what make a difference in this. but answer should be same. The answer will be same. So now, in my opinion, what I prefer, I wanted to shift this point to this way. I wanted to shift this way. Okay, my aim is to shift a summing point before G2. Okay, that is what we wanted to do. So this is one kind of rule. That, as I told you, 8 to 10 rules are there. So two rules we have seen just now. One is blocks in cascade. Another rule is when the blocks are in parallel. So now in this case, I wanted to move this to this side, and the movement should be in such a way that it should not affect the performance of a system. So performance should be intact, it should not get affected. अब कैसा होगा यहाँ पर, if you wanted to move this to here, now see, again we'll assume this as A. Okay, this is getting G2A, or A G2 we are getting here. So if suppose this is something which is B here, so here I am getting as H3B. At this point I am getting as G2A plus H3B, and that is what we have to take care of. When you are moving it, it should not get affected. That we have to take care of. Okay, understood this? Now, so if I move this, I'll move it like this. This is G2. So instead of going this point there, it will come here as minus. Okay. So we have moved them, and at the same time I told you that I don't want the performance of the system to get affected. तो यहाँ पे we should get it as G2A and H3B, that much only. अब क्या हो गया कि when I moved it here, so what happened? If you consider the path of A, so here A will appear as it is, okay? Here A will appear as it is, and G2 will be multiplied to the A, so I am getting this as G2A there. I am getting it as it is. Okay, I am getting it as it is. तो ये पाथ में there is nothing, no change in performance of A is appearing as it is. अब if you see that ये वाला जो portion आ रहा था B की तरफ से, that H3B is coming here and G2 is multiplying with the H3B. तो यहाँ पर क्या हो रहा था? I am getting extra point here as that G2 is getting multiplied to the H3 as well, and that is what I don't want. So what I should do it now in such scenario, I should add one block here. That block, what that block will do? That block will divide the system with G2B. Okay, so here what I will be getting? Here I will be getting H3B upon G2. Okay, and that G2, if it is getting multiplied, so that G2 will get cancelled with each other, and ultimately at the end I will be getting whatever I wanted initially. So I was successful in moving it. So what happens? So the rule is, what the rule says, the simple way, if you want to remember the rule, I'll write down rules as well in between. So if two blocks are there in cascade, so these two blocks can be replaced with a one block mentioning G1, G2. This is our first rule. Okay, first rule was this. Okay, what second rule says? The second rule said कि if you find blocks in parallel, blocks in parallel, just add or subtract them. So I'll be getting here the output as this is replaced, this particular thing can be replaced as G1 plus G2 minus G3. This particular thing can be replaced as this. Okay, this is second rule. Okay, and now just now what we have seen as a third rule, we have seen as a third rule कि in case when you wanted to move the block, okay, sorry, this block wasn't here, we wanted to move that block, यहाँ से ऐसा था, okay, this is block and this is path, okay, यहाँ से this was a path and this is output. So in this case we wanted to move summing point ahead of a or before block, move. So what, this is third rule, I'll say is third rule. The sequence first, second, third, I don't know whether how they are writing it out. The way we are getting, we are calling it as third rule, the way we are getting it. Basically the thing is the important point in this is we wanted to move summing point before block. Okay, if you wanted to move before block, summing point before block. So in that case what we have done, we have moved the block, okay, G1. Only the thing is we have divided here that G1 so that it should not get affected. Whatever way coming out here, we have divided that and we will be able to move it. So that is what we have seen in it. So done with this. So iska matlab we got it like this. So I have okay, that is good. Now you can see that G2 and G3 are in series. G2 and G3 are in series, and here H3 and 1 by G2 are in series. H3 and 1 by 2 G2 are in series. So I can replace this block, these two blocks, with a one block, and my new block will be like this. Here this block will be G2 and G3, multiplication of that. Okay, or here as well ये दोनों block भी this can be replaced with one block. I'll be getting that one block as H3 divided by G2. Got it? Understood this? Now we'll move to the next rule. Now in this case, now what you can see that we have reduced it. Furthermore, if you move this to that side, these two will come in cascade. This two can come in cascade, or we can interchange them. So that is another, it added to the another rule. So what happens? I'll say that now my fourth rule, which is coming in my picture, the fourth rule, what fourth rule says? The fourth rule says that you can interchange the blocks. Okay, there is no affection, there is no change in it. If we say that see if I have this as A, this is B, this is C. So what I'll be getting here, A minus B. Okay, what I'll get here is A minus B minus C. So either you write it as A minus B or minus C, or you write it as A minus C minus B. Nothing will change. So this could be interchangeable. I could have here A and C first. So A is getting minus with C, and then I will have here B. So I'll get it as A minus C minus B, so which is same as that. This is fourth rule. Okay, interchangeability of a summing point. It could be interchangeability of anything. It could be of a summing point, it could be of a block, it could be of a takeoff point. Nothing is getting affected because of it. So interchangeability, as per that interchangeability rule, if you remember in this diagram, we can replace them. Okay, so what I'll do is I'll say that instead of going it here, this particular thing is coming to this with minus sign. Okay, and instead of it going here, it comes to this with a minus sign. So I have to replace this as well. Got it? Okay, so we have four rules. So we have just seen in this diagram. As per this example, we have seen four rules, and we can see that your block diagram is even reduced. Now if you observe this particular kind of thing is making a kind of feedback loop. This is making a feedback loop. This is making a feedback loop. In this case, we are having G2, G3 and H2. So this add to one rule. This add to one rule, which we call it as rule number, which rule number 5, and that is feedback loop. That rule is feedback loop. So as per that feedback loop, if you find out two things, one as this, and it is getting feedback here as H1 and is giving feedback here as either plus or minus. So this can be replaced with one block. Okay, and the system is in such a way that the forward gain will appear here as it is. Remember this, forward gain will appear in the numerator as it is, and then here in the denominator we'll write it as 1. If this is plus, then we should write it as minus, and if it is minus, we should write it as plus. Okay, so that we have to do. Let me check it out once. Correct. Because what happens, no, a negative feedback will make system more stable. A positive feedback will make its system unstable, kind of unstable. So we'll get it as forward multiply by feedback. So forward multiply by feedback gain. This is the way we can write it also. इधर ऊपर जैसा गेन लिखा और नीचे 1 माइनस उल्टा किया, मतलब प्लस है तो माइनस और माइनस है तो प्लस. Now we'll go to our example. In this example, I can replace the whole thing by one block, and that block we can write it as what I said. We have to write down feedback, that feedback gain, forward gain as it is. So I have written is as it is. Then what it says, then divide this thing with 1. We have it is in minus sign, so we have to write it as plus. Then this multiply by this, so we'll have G2, G3 multiply by H2. And this is now reduced. Now this will be there. This is what we made it. We made a connection like this. Okay. Now these two are in cascade, hai na? These two are in cascade. So if they are in cascade, I can write it as, instead of showing this separately, I'll write down this as G2, G3, G4. वो कैस्केड में था तो it is appearing in a numerator. अब now again you can see a feedback here. Again you can see a feedback here. Kind of feedback loop provided here. And once initially when you start there, you have to think a little bit. Once your path is identified, you start working on that path, you will get a destination, you will reach near to the destination. So up now in this case, what we have, G3, G2 as a feedback. So this in all together, this is with a negative feedback. So we will be having G2, G3, G4 in the numerator as it is. I'll write somewhere here first, then we'll copy it there. Okay, G2 G2, G3, G4 as it is. We got G2, G3, G4 as it is. We'll divide it. Okay, we'll write again this as it is 1 plus G2, G3, H2 as it is. Okay, कैसे किया? G2, G3, G4 plus 1 plus ये ऐसे के ऐसे ही लिखा. Next thing what you have to see is either minus है कि plus है. If this is minus, you write here as plus. इसका काम खत्म हो गया. Okay, इसका काम खत्म हो गया. If this is minus, we have to write there as a plus. अब इसके बाद में क्या था? This multiply by this will appear here. So we will have G2, G3, G4 multiply by H3 divided by G2. Got it? Okay, and G2 will cancel each other. G2 will cancel each other. So this is the simplest way to write it down. Okay, so I can replace whole thing this as with a one block. Okay, and that block is like this. वो ब्लॉक क्या रहेगा? G2, G3, G4. Let me see that whether you are able to identify that. Okay, दिखता तो है. I'll not use next time this dark blue. 1 plus G2, G3, H2 plus G3, G4, H3. G3, G4, H3. Got it? Understood this? अब इसके बाद में ये हो गया हमारा this block is also got removed, no? ये भी रिमूव हो गया. Okay. Now these two are in cascade. They two are in cascade. बराबर है ना? They two are in cascade. So we have to replace it by one bigger block. Okay, I'll replace this one bigger block. Okay, the thing in the numerator will remain as it is there. The thing in the denominator will remain as it is, and or I'll write it again here. For us, we'll have as it is 1 plus G2, G3, H2 plus G3, G4, H3. There is no need of this, na? So I'll remove this. Okay, अभी लिख दिया मैंने. And what ये जो ऊपर था G2, G3, G4, that thing G2, G3, G4, it will get multiplied with the G1 plus G5. Now this block is reduced. This block is no need of this block. Okay. Now you can observe a feedback loop here. Again a feedback loop here. A kind of a feedback loop here. Now I told you how to write down. We are not disturbing this. We are keeping it as it is. Okay. और ये we have written as it is 1 plus G4 G3 H2 plus G3 G4 H3, ये as it is लिखा मैंने. ओके, we have written as it is. और क्या करना था, ये जो फीडबैक था तो we'll write it as प्लस न्यूमरेटर यानी G2 G3 G4 multiply by G1 plus G5 multiply by this feedback. ऐसा लिखने को बोला था. If you remember, to remember this, तो मैंने क्या किया, I have replaced this loop. We replace this loop, so we got a performance like this. Now you can see that these are forward path. So these are forward path. So ultimately this G6 will also go out. So what I'll get it? I'll get it as this G6 will appear here. It will get added, and now our system will be like this. So we are getting it. This is the final output. This is our final output. So we can write down this transfer function. Transfer function means output upon input. So in transfer function there is no use of any power supply. Supply we are not considering. We are considering only input and output. So output upon input, what we have got it as G6 plus G2 G3 G4 G1 plus G5 divided by 1 plus G4 G3 H2 plus G3 G4 H3 plus G2 G3 G4 G1 plus G5 into H1. This is final transfer function. This is our final transfer function. This is our final transfer function. So in a nutshell, block diagram reduction technique, we started with the block diagram reduction technique. Okay, we say that in control system it is very necessary for us to reduce the system multiple block diagrams into a one block diagram, so that the parameters can be easily analyzed. Parameters such as its performance, frequency response, such as stability, and other criteria which we wanted to apply to identify, to analyze the system, could be easily applicable to it. So we are going with a block diagram reduction technique, and we have started with an example, and in that, while solving that example, we have come across certain rules, as I told you. So it may be possible that for a particular kind of a sum we apply few less rules or multiple rules. So one rule number 5 that we have seen is a feedback loop. तो feedback loop का rule ये था कि we can replace, if you find a feedback path, जैसे मैंने आपको forward path बताया था, feedback path बताया था, summing point बताया था, forward gain बताया था, feedback gain बताया था, take off point बताया था. Okay, these were the parameters which are there in any kind of a block diagram. अब ये block diagram में there is a feedback path, there is a forward path. To replace that with one block, we have to go with this rule. This is rule number 5. Then we have seen this फर्स्ट एंड सेकेंड रूल कि इफ दे आर इन कैस्केड वी हैव टू मल्टीप्लाई, इफ दे आर इन पैरेलल व्हाटएवर नीडेड, प्लस है तो प्लस, माइनस है तो माइनस। नेक्स्ट टू दैट इज फोर्थ रूल जो हमने देखा था, वो फोर्थ रूल में हमने क्या किया था कि दे आर एसोसिएटिव, दे कैन इंटरचेंज, दे आर एसोसिएटिव, सो ऑल योर गेन either feedback or forward, your blocks means those are blocks, or you talk about summing point or a takeoff point, they can be interchangeable. The next thing what we have seen is here third rule में क्या देखा था हमने कि third rule में देखा था कि we can move this ahead or afterwards, only the thing is we have to divide it. और अगर ये तो समिंग पॉइंट के साथ हो रहा है, ऐसा ही अगर टेक ऑफ पॉइंट के साथ होता तो we can do it in the same way, यानी वो हमारा एक और रूल बन जाता। यानी कौन सा रूल बन जाता? we'll say that next rule कैसा रहता है कि if this is a block diagram and you have a take off point here, okay, and if you want to move this take off point, ये जीवन है, अब इसको अगर मूव करना रहता अपने को, इसको इधर लाना रहता, तो वी हैव जीवन हियर, ओके, वी हैव मूव्ड इट, तो अब मूव करते अब क्या होता, यहाँ पे जो मूवमेंट थी जीवन दोनों को मल्टीप्लाई था, यानी यहाँ पे x था, यहाँ पे जीवन x होता, ओके, और यहाँ पे y था, तो वील गेट इट हियर जीवन x और y। टेक ऑफ पॉइंट ऐसे नहीं होएगा ना, टेक ऑफ पॉइंट तो बाहर निकलने वाला एरो रहेगा, ऐसा रहेगा एरो, ऐसा नहीं रहेगा ना। तो वी आर टेकिंग g1x हियर, वी कांट से दिस एज y, क्योंकि वो टेक ऑफ पॉइंट है, टेक ऑफ है ना, टेक ऑफ लेके जा रहे हैं, तो वी हैव टेक ऑफ पॉइंट हियर, तो ये g1x आएगा। अगर आपने यहाँ पर ऐसा लिखा, सॉरी यहाँ पे भी डायरेक्शन थोड़ा बदलना पड़ेगा मेरे को, आई विल से दैट इन दिस डायग्राम वी विल हैव इट। तो यहाँ पे क्या हो रहा है, यहाँ पे वो आदमी x ही लेके जा रहा है, एक्चुअली यहाँ पे तो g1x मिल रहा है, यहाँ पे x ही लेके जा रहा है, दैट व्हाट वी डोंट वांट, वी वांट g1x टू बी टेकन आउट, तो टू टेक इट g1x तो वी हैव टू मल्टीप्लाई हियर g1x, तो वी विल बी टेकिंग g1x। तो यानी क्या होता है, उसमें डिवाइड किया था, इसमें अपन ने क्या किया, मल्टीप्लाई किया, ओके। ये एक रूल की तरफ लेके जाता है अपने को, विल से दैट सेवेंथ रूल, ओके। और एक रूल की तरफ अपने को लेके जाएगा, वो चीज एट्थ रूल की तरफ, कि अगर ये आगे करना है तो जैसा वो बिफोर था, वो समिंग पॉइंट था और ये ऐसे था, ऐसे रहा, तो x आया, y आया, ऐसा आया, तो यहां पे क्या मिल रहा है, g1 x प्लस y, अगर ये प्लस है तो। लेकिन अगर अपने को इसको इंटरचेंज करना है, यानी हियर वी वांट g1 और इधर अपने को समिंग पॉइंट डालना है, तो यहां पे अपने को अल्टीमेटली क्या मिलना चाहिए, g1 x प्लस y, बराबर है ना। और वी कैन राइट दिस एज g1 x प्लस g1 y, ये चाहिए अपने को, तो ये चाहिए, तो अपने पास x तो इधर से आ रहा था, g1 x मिल गया। अगर y अपना इधर से आ रहा है तो वी हैव टू टेक केयर दैट वी शुड बी मल्टीप्लाइंग बाय वेल g1 अगेन, तो वील हैव g1 y, तो यहाँ पे g1 x प्लस g1 y मिलेगा। तो यानी ये चीज है कि जब आप समिंग पॉइंट, यानी ये रूल में क्या था, समिंग पॉइंट आफ्टर द ब्लॉक, तो ये चीजें आप ध्यान रख सकते हो याद, जब भी अगर ध्यान नहीं है तो आप करके देख लीजिए खुद, यू विल बी एबल टू रिमेंबर। वो जो रूल है अच्छा है अगर याद रहे तो, अगर याद नहीं रहे तो ज्यादा परेशान होने की जरूरत नहीं है। यू कैन डिवाइस, यू कैन डिराइव देम, दे ऑल आर डिराइवेबल, यू कैन देन विद अ सिंपल मैथमेटिक रूल दे आर डिराइवेबल लाइक वी डिड इट। तो आफ्टर द ब्लॉक करना है तो मल्टीप्लाई करना है, और बिफोर द ब्लॉक करना है तो डिवाइड करना है, दिस इज ओनली अ रूल। और ये चीजें क्या है ना, ये दिस इज एट्थ रूल। अब नाइन्थ रूल यही सेम अपन टेक ऑफ पॉइंट के साथ में भी, जैसा अपन ने किया ही था टेक ऑफ पॉइंट के साथ में, यहाँ पर टेक ऑफ पॉइंट के साथ में किया था कि समिंग पॉइंट इस ब्लॉक के बिफोर था, आफ्टर किया, तो ये सब चीजें हैं और दीज थिंग्स आर इंपॉर्टेंट। आई होप यू अंडरस्टूड this kind of technique here, and thank you very much for this lecture. I hope you will be available for my next lecture soon. Bye.